Hi, and welcome to this instructional video by See Your Future. Today I will be discussing the questions, what is friction? Before we can understand how friction works, we first need to understand forces. A force is any influence that causes an object to undergo a change in motion or direction. There are several different types of forces, and all forces can be placed into two broad categories: contact forces and action at a distance forces. Contact forces include frictional forces, buoyant forces, normal forces, and drag forces. At a distance forces include electrostatic forces, gravitational forces, and magnetic forces. If no forces are acting on an object, or if all of the forces acting on an object cancel out, then an object that is in motion will stay in motion, in the same direction, and at the same speed forever. Or if the object is stationary, then it will remain stationary. Newton's first law of motion summarizes this phenomenon quite well. The first law of motion states that if there is no net force on an object, then its velocity will be constant. Forces can be calculated using Newton's second law of motion. Newton's second law of motion states that the acceleration of a body is parallel and directionally proportional to the net force acting on the body, and this is inversely proportional to the mass of the body. In other words, force equals the mass of an object times the object's acceleration. Make sure you remember this formula, it will be very important. This simple equation can be used to calculate the net force or the combination of every force acting on an object in almost any situation. For example, let's look at a soccer ball. Kicking a soccer ball, for instance, is an example of a contact force that causes the soccer ball to change velocity from a stationary state to one that is moving. However, as we know from experience, the soccer ball does not keep on rolling forever. There is a force acting on it in the opposite direction of motion, causing it to slow down. This force is the force of friction. Friction is all around you. Without friction, the soccer ball you kicked would keep rolling forever. Without friction, you would not be able to pick anything up because it would just slide out of your hand. You wouldn't even be able to stand up because you would just slip and fall. It would be like trying to walk on the most slippery ice you can imagine. Friction is a force that always acts in the direction opposite to motion. No matter which direction you move something in, friction pulls it the other way. Move something to the left, friction pulls it to the right. Move something forwards, friction pulls it back. Friction is actually a force that appears whenever two things rub against one another. Although two objects might look smooth, microscopically they are rough and jagged. As they slide against one another, the contact is anything but smooth. They both grind and drag against one another. And this is where friction comes from. There are two types of friction: static friction and kinetic friction. Static friction is a force resisting any motion between solid surfaces. Imagine you have a heavy crate resting on the floor in a warehouse. You push it horizontally with a steady force, but it does not move. This is because the force that you apply is balanced by a frictional force exerted horizontally on the bottom of the crate by the floor and opposite to the direction of your force. Remarkably, this frictional force automatically adjusts itself in both magnitude and direction to cancel exactly whatever force you decide to apply. Of course, if you push hard enough, the box will eventually move. The force at which the crate starts moving is called the breakaway force. Of course, even once the box starts moving, there's still a force of friction acting on it, and this is kinetic friction. Kinetic friction is the force resisting the relative motion between two solid surfaces. For example, the soccer ball we mentioned earlier experienced kinetic friction that causes it to slow down and eventually stop moving after you kick it. From everyday experience, we know that friction depends on what is called normal force. Normal force is how hard two objects are pushing against one another. For example, if you put your palms together lightly and slide them back and forth, it's not too difficult. But if you push your palms together and try to slide them back and forth again, it becomes a lot harder. This is because of friction. In most real-world applications that you'll be looking at an object sitting on a flat surface. In this case, the normal force will just be equal to the force of gravity acting on the object. The force of gravity can be calculated by multiplying the object's mass times the acceleration due to gravity, which we call g. On Earth, g is equal to 9.8 meters per second squared. As you've probably guessed by now, it is actually possible and actually quite easy to calculate the force of friction. The force of friction, as you know, is dependent on the normal force as well as the roughness of the surface it is sliding on. This roughness is quantified in what is called the coefficient of friction. The coefficient of friction has the symbol mu. The force of static friction uses the coefficient of static friction, labeled mu sub s, and the force of kinetic friction uses the coefficient of kinetic friction, labeled mu sub k. And this is for static. And so from this, we can reason that the force of friction is equal to the normal force times mu. Depending on whether we're looking at the static friction or the kinetic friction, it would be mu sub s or mu sub k. As we know, the normal force is equal in most situations just to the force of gravity. So, this is the equation of friction for an object on a flat surface. Alright, let's look at an example. Imagine you have a block of mass 50 kilograms sitting on a flat surface with a coefficient of static friction of 0.73. With what force would you need to push this block to make it start moving? Okay, so this is just asking for the breakaway force. Now, to calculate the breakaway force, we can just write down the regular equation for friction that we have. So we have the force of friction equals normal force times mu s. Because we're looking for the force of static friction. We know that since it's on a flat surface, the normal force will be equivalent to mass times the acceleration due to gravity times mu s. We know that mass is 50 kilograms. We know that g is equal to 9.8 meters per second squared. And we know that mu s is 0.73. So we have everything we need. So let's plug them in. And you multiply these together, and you get (357.7 kilograms meters per second squared). And this is equal to the unit called the Newton. So the unit for force is called the Newton and is equivalent to kilograms times meters per second squared. Alright, let's look at another example. Imagine you have a block of mass 50 kilograms sitting on a flat surface with a coefficient of kinetic friction of 0.42. How fast would a block accelerate if you were pushing it with a force of 5 newtons? Okay, so this one's a little bit more complicated because there's more than one force acting on the block. But we can still do this. So, we have a block here, and you're pushing it with a force of 5 newtons. However, there's a force acting against it, and this is the force of friction. So we have to calculate the force of friction, and we'll do it in the same way we did for the previous problem. Except in this situation, we're looking at the force of kinetic friction. So we'll be using mu k instead of mu s. So the force of friction is equal to the normal force times mu k. And like we said before, since the block is on a flat surface, the normal force will just be the force of gravity, which is mass times g. And you multiply this by mu k. So now we know everything we need. We know m, which is 50 grams. We know g, which is 9.8 meters per second squared. And we know mu k, which is 0.42. So let's just plug them in. We have 50 kilograms times 9.8 meters per second squared times mu k, which is 0.42. As you may have noticed, mu is always unitless. And we calculate that out, and that equals 205.8 newtons. Okay, so now that we know both forces, we can calculate the net force. For this example, let's imagine that this is a positive direction and this is a negative direction. This means that the force you're exerting on the box, the 5 newtons, is pointed in the positive direction, while the force of friction will be pointing in the negative direction. So, to calculate the net force, you would have the 5 newtons you're exerting minus the 205.8 newtons that the force of friction is exerting on the box. So this means you will get negative 208 newtons as your F net. Okay, so we have a net force acting in the negative direction, and this is fine. All this means is that we're going to have a negative acceleration. Okay, so we know that the net force is equal to mass times acceleration. And that is equal to negative 200.8 newtons. Okay, we know what mass is, and we know what acceleration, and we're looking for acceleration. So, acceleration equals negative 200.8 newtons over the mass. So I just cleaned everything up a bit. But now we know that acceleration would equal negative 200.8 newtons over the mass, which is 50 kilograms. and this would be an acceleration of negative 4.02 meters per second squared. So what does this negative acceleration mean? Well, a negative acceleration means that the box is slowing down. It will be accelerating in your direction, in the negative direction. I hope you enjoyed this video and found it to be useful. If you have any questions about what was shown in this video, please post them in the comment box below. If you have a question about another topic, please send us an email at questions@syfuture.org. Also, take a look at our YouTube channel for a full list of instructional videos. You can access this channel through our website, www.syfuture.org. Thanks for watching!